Hello and welcome to Quantum Pi. So this is the third lecture of the series and we'll be continuing with the number system, and today we will be learning how to find the units, digits and the trailing zeros. Okay, so before solving all the PYQs, let me brief you with the concepts of units, digit and the trailing zeros. Let us start with finding the units digit. Right. So the units digit is your ones digit, right? So if I ask you what is the units digit of 2 into 7 into 18 into 344, what would you do? Just multiply the units parts. So 7 twos are 14, 4 is your units digit, 4 6 24, again 4, 4 4 16. So 6 is your final units digit. This is your units digit. So sometimes your question would be like 247 into 345 plus 642 into 349. In such questions, please do remember that you have to follow the BODMAS rule. So we have multiplication and we have addition and multiplication here, right? So first go with the multiplication part. First go with the multiplication part. So yeah, 7 fives 35, 7 fives 35. So 5 is your units digit, and we have multiplication here. So 9 2 is 18, 8 is your units digit, and we have to add them. So 8 and this is 13. So your final units digit is 3. All right. Yes. So these are the basic things. You already know these things. But now let us see how do you find the units digit of some bigger numbers like 347 power 245 into 643 power 547 into 729 power 843. So such questions we will see how to find the units digit. Before that, let me explain you how the units digit behaves when it comes to this larger numbers. So let me explain you a few things. First, let's see the power of 1. 1 power anything, 1 power anything will give you 1 as a units digit. Let us see about 2. Let us check the powers of 2. So 2 power 1 will be 2. 2 square, 2 twos are 4. 4 twos are 8. 8 twos are 16. 6 twos are 12. 2 twos are 4. 4 twos are 8. 8 twos are 16. So you are getting 2486 and 2486. So this is being repeated, right? So power of 2 would be only 2486, nothing else. Let us see the power of 3's. Power of 3 power 1 is 3, 3 square, 3 3 is 9, 9 3 is 27, 7 3 is 21. So these are the units digits of 3, 3 powers. Now again it continues. 1 3s are 3, 3 3s are 9, so it's the same thing. This is a cycle, it repeats. Let us check power of 4's. 4 power 1 is 4, 4 4 16, 6, 4 6 fours again 24, again 4 4 16. So your cycle is 4 and 6, it keeps repeating. 5 power anything will give you only 5 as your units digit. 6 power anything will give you again 6 as your units digit. 6 6 36 36 6 216. Now let us check the power of 7's. 7 power 1 is 7, 7 7 is 49, 7 9 63, 7 3 is 21, again 7 1 is 7. So this is what is being repeated. Let us check power of 8's. 8 power 1 is 8, 8 8 64, 8 4 is 32, 8 2 16. Let us check power of 9's. 9 power in 1 will be 9, 9 9 is 81, again 9 1 is 9, 9 9 is 81. So 1 1 1, 9 and 1. 9 1 9 1 9 1, it keeps repeating. So if your unit digit ends with 0, its units also ends with 0. So this is the overall view of all these numbers, all these digits ka units digits, powers, right? Yes. Now, see, you need not mug them up. You can right away do it in your examination. If they are asking some power of 8s, you just write it 8 8 8 64, 8 4 32, 8 to 16. That's it. 8 4 2 6. So you need not mug them up. You need not waste time mugging them up. Now, sir, so if I ask you what is power of 2 power 5. So 2 power 5 is nothing but, this is 2 power 1, 2 square, 2 cube, 2 power 4, and this will be again 2 power 5. So 2 power 5 units digit is 2 power 5 units digit again 2. What if I ask you 2 power 7? The units digit is 2 power 1, 2, 3, 4, 5, 6, 7. So you'll get 8. So 2 power 7 units digit is 8. 2 power 7 units digit is. Likewise, so you can solve the units digit of all other numbers, sir. So if it is a very big number, for example, if I give you 2 power 145, you wanted to find the units digit of this. So you understand that for every 4 powers, this cycle is repeating 2486, 2486. So in 145, let us check, let us divide by 4 and let us check the remainders. So if I divide by 4, what is the divisible rule of 4? The last two digits, right? 44 goes with it. So remainder is 1. So 144 exactly goes with 4. So some fixed cycles are already done. So you are left with remainder 1. That means this units digit is as same as 2 power 1, which is nothing but 2. If it is 2 power 147, 144 goes with 4. So this is, you are left with, out of 144, out of 147, 144 is gone. So you are left with 2 cube, which will give you 8. Right? This is your unit digit. So when you get remainder 1, so I can tell you that you get the first one if remainder is 1. You get this when the remainder is 2. You get this part when the remainder is 3. You get this part when the remainder is 0. You do not get a remainder 4 when you divide a number by 4. You get remainder 0, 1, 2, 3, right? So 1, 2, 3, 4. The same. This is all remainder 1. These are all remainders 2. These are all remainders 3. These are all remainders 0. Sir, see, because this cycle is repeated after 4 repetitions, right? So you have to divide by 4. What about 4 and 9? You have to divide it by 2. But I don't want you to get confused. What I suggest you is, you think this is a cycle of 4 only. 4, 6, 4, 6. This is also 9, 1, 9, 1. This is 6, 6, 6, 5, 5, 5. And these are all 1, 1, 1. Right? So power of any number, just divide by 4. Just divide by 4. And check the remainder, and based on the remainder you can tell the unit digit. Now let us go and solve the previous problem. Yeah, this one, sir. So your unit digit is dependent on 7, here on 3, here on 9. So 7 power 245. Let us divide 245 by 4. What is your remainder? uh, when you're dividing by 4, you have to remember the last two digits are only necessary, because you already learnt it in the divisible rule of 4. The last two digits should be divisible by 4. So 45 by 4, 44 goes, so remainder is 1. So 7 power 1 is 7. Next, into here 44 goes again, you are left with 3. So 3 cube. What is 3 cube? What is 3 cube? 3 3 is 9, 9 3 is 27. Again here units is 7. Here units is 7. Here 40 goes, so you're left with 3. So 9 cube, 9 9s 81. Again 9 1s 9. So this is your unit digit 9 for this. Now let us check the final unit digit. 7 7s 49. So this gives you 9. 9 9s 81. So this gives you 1 as your unit digit. So your final unit digit for this is 1. This is your final answer. I hope the concept is very clear. Now let me give you one more question. Find the units digit of, find units digit of 1 power 242 plus 2 power 242 plus 3 power 242 plus so on plus 9 power 242. As I said, you forget about what you have to divide with. You just have to divide with 4. That's it. 242 divided by 4. Yeah, your remainder is 2. Remainder 2 means what? 1 square, 2 square, 3 square. That's it. 1 square. Units digit 1. 2 square 4. 3 square 9. 4 square 16. 5 square 25. 6 square 36, 7 square 49, 8 square 6 64, 9 square 81. That's it. So this should be your final unit digits. Yeah, add them up. 9 plus 1 is 10, 10, 20, 30, 40 and 5. So your final sum is 45 and your final units digit is 5. Units digit is 5. I hope the concept of units digit is very clear to you. We already solved some questions on units digit in the lecture 2 as well. Now let us move on to learning the concepts of trailing zeros. Learn the concepts of trailing zeros. So trailing zeros are the zeros at the end. Zeros at the end. For example, 27500. Here, how many trailing zeros? There are two trailing zeros. 2002. How many trailing zeros? You have zero trailing zeros because trailing zeros must be at the end. Okay. So for this, you have to understand factorials because most questions come down from factorials. For example, you need to find trailing zeros in 100 factorial. Trailing zeros in 100 factorial. So 100 factorial is nothing but your 100 into 99 into 98 so on till 3 into 2 into 1. You cannot multiply this. You cannot multiply this. So how to do? But one thing I can tell you that a 5 into a 2 will give you a 10. Nothing but one single 5 and one single 2 will give you one single trailing zero. So we have to check how many 5s are in this, how many 2s are in this. So based on that, you can clearly tell how many trailing zeros would this product have or with this 100 factorial would have. Now, how to find the number of 5s in this product? Will you count them? In 100, how many 5s are there? In 95, 95, 10, 15, everywhere 5 is there, right? So how do you do that? It takes time, right? So if they give you some 500 factorial, you cannot waste your time by counting all those 5s. So the best way would be this. Let me tell you how to find the power of a prime number in n factorial. Power of a prime number in n factorial. Now we wanted power of 5. Power of 5 in 100 factorial. You wanted the power of 5 in this 100 factorial. So what you should do is, just like prime factorization, you are going to factorize with 5. Only with 5 because you are finding the power of 5 in 100 factorial. So 5 2s 10 as it is. 5 4s are 20. 5 4s are 20. That's it. Except this, you add this. You are getting 24. So the power of 5 in 100 factorial is 5 power 24. Now also find the power of 2 because you wanted to get a 10, right? Because you wanted to find the trailing zeros. So you know in 100 factorial there are 24 5s. Also find how many 2s are there. Let us do it here. 2 50s, 2 25s, 2 12s. Forget about the remainder. 2 12s 24. Forget about the remainder. 2 6 12, 2 3 6 and 2 1s 2. Forget about this and add these all. 50, 75, 85, 87, 87, 90, 96 and 197. So the power of 2 is 97. So in 100 factorial, now you know the power of 5, you know the power of 2. So you would know how many zeros can be formed. So there are 24 5s, there are 97 2s. So definitely each 5 and each 2 will give you 10, right? Each 5 and each 2 will give you 110. So 24 5s you have and you also have 24 2s. You definitely have 97, but in that you have 24 2s. So these 24 5s and these 24 2s multiply and they form 24 tens. So 10 power 24. So now you can tell that how many trailing zeros are there in 100 factorial? There are 24 trailing zeros. Am I clear? Am I clear? Apart from trailing zeros, they would also ask you just the power of 10. What is the power of 10 in 100 factorial? It is clearly 24. 10's power is what? 24. Let me give you one question. Find power of 7 in 100 factorial. Find power of 12 in 100 factorial. Yeah, let us solve this. You will get your concepts very clear when you solve this. Sir, now this power of 7 in 100 factorial. In 100 factorial, you want the power of 7. So 7 1 7, 30, 7 4 28, 7 2 14. That's it. Forget about this, add this. I'm getting 16. So power of 7 in 100 factorial is 7 power 16. They'll ask you what is the power of 12. Now again 12, 100, yeah, 12, 5, 60, 72, 84, 96. Yes, you get 96. 12 8's 96. 12 8's 96. Anything else? Yeah, that's it. So power of 12 would be 12 power 8. Yes. So this is a very bad way of doing it. This is absolutely wrong. This is absolutely wrong because I clearly told you that it is a power of a prime. It is a power of a prime in n factorial. Because this 12 is not prime. This is not prime. You cannot proceed with this method. So how did we do for power of 10? Power of 10, power of 10, this is 10 is also not a prime number. So we found the power of 5s and power of 2s. Then we found out the power of 10. Similarly, when you wanted to find the power of 12, you have to find power of 4 3s are 12. 4 3s are 12. You need to find the power of 4s and power of 3s here. So to find the power of 4 is also a composite number. No, sorry. Yeah, it is also composite number. Um, so basically this is nothing but 2 square. This is nothing but 2 square. Now you can easily find power of 2s and power of 3s. Already we found the power of 2s in 100 factorial. How many 2s are there in 100 factorial? 2 power 97. In the previous question we already did. Power of 2s is 2 power 97. 2 power 97. Let us find power of 3s. Power of 3s in 100 factorial. Yeah. 3 33s, 3 11s, 3 3s 9, and 3 1s 3. So this is gone. This is 44, 48, 48. Yeah. So you got 3 power 48. So power of 2's in 100 factorial is 97. Power of 3's is 48. Now you wanted to find power of 12's. So you should know how many 4's are there. Instead of 2 power 97, I'll write this as 2 square, and this is 2 4's 8, 2 8 16 into 2 into 3 power 48. This will give you 48 2s are 96, and this 2 power 1 97. So this is nothing but 4 power 48 into 3 power 48, and we also have an extra 2. So how many 4s are there? 48. How many 3s are there? 48. So how many 12s would be formed? Each 4 and each 3 will give you 112. So we have 48 4s and 48 3s. This will give you 48 12s. So what is the power of 12 in 100 factorial? It is simple 48. What is the final answer? 12 power 48. I hope the concepts are very clear. So we have done with the concepts of units digit and also factorials and finding the trailing zeros. I have briefed the concept. I made sure that these concepts are cleared in just 15 to 20 minutes. Now let us start solving some problems. So let us look into this problem. This is your UPSC CSAT 2024 problem. So all the PYQs, whatever I'm giving you, are from your PYQs of Civil Service Paper 2. You can pause the video and try to solve it yourself so that you can apply all the concepts that you have learned before. So this is a very simple question. How many consecutive zeros are there at the end of the integer obtained in this product? So the product is 1 square into 2 power 4 into 3 power 6, so on till 25 power 50. So it's 1 and it's double par. 2, it's double. 3 double. 25 double par. All right. So they're asking consecutive zeros. Nothing but at the end of the integer. Nothing but he's asking the trailing zeros. He's asking the trailing zeros. He's asking the trailing zeros. So to find the trailing zeros, you should know how many 5s are there here and how many 2s are there. See, you have to observe one thing. Definitely, the number of 5s would be lesser than number of 5s would be definitely lesser than number of 2s, because the 2s would be more in number. Even if here there are only 24 5s, but in 100 factorial there are 97 2s. 2s are more in number. So definitely here as well, power of 2s would be more. So just find the power of 5s. Just find the power of 5s. Let us check where all we have 5s. In 1 square, no 5, 2, 3, 4, yeah. And 5. We have a 5 here. 5 power 10. Here between we had a 5 power 10. Next we have 10 power 20 as well. Into we have 15 power 30. We have 20 power 40. We have 25 power 50. So these are all the numbers which have 5 in it. How many 5s are there here? 1 5. So 5, 5 power 10, right? So we have 10 5s here, plus we have 25s because this is 5 into 2. So 5 power 20 is here. So we have 25s. Here we have 35s. Here we have 5 fours 20, no? So we have 40, plus here observe, here we have already 25 is 5 square and whole power 50. So this is 5 power 100. So in this we have 100 fives. We have 100 fives. So overall 100, 140, 170, 190, and we have 200 fives in this product. So there are 200 fives and definitely 2s would be more than 200. So how many zeros would it form? 200 fives and 200 2s will give you 200 zeros. Will give you 200 zeros. I hope the explanation is clear, right? I hope the explanation is clear. Now let's move on to the next question. What is the rightmost digit preceding the zeros in the value of 30 per 30? So the digit preceding the zero. So there are so many zeros. So he is asking the non-zero. Basically, he is asking the non-zero integer. This one, which is non-zero. Non-zero integer is asking. All right. So 3 per 30 is nothing but, 30 per 30 is nothing but 3 into 10 per 30. So this is 3 per 30 into 10 per 30. See, 10 per 30 you will have obviously 10, 10, 10. How many? 30. So you have 30 trailing zeros. You have 30 trailing zeros. But I wanted the non-zero digit before these. So 3 per 30. So find the units digit of this. 30 when divided by 4. I already told you 30 divided by 4. You just have to divide by 4. Remainder is 2. So this is nothing but this units digit as good as 3 square. Sorry, 4. So yeah, 3 square. What is 3 square? 9. So your units digit would be option D, 9. Am I clear? Yeah, let's move to the next question. So this is your 2024 question. The previous one is also 2024. Yeah, this is a very simple question. See, some questions are mixed in numbers, some in the divisibilities also. We have solved some questions on university yesterday in the previous class, in the class 2. So yeah, so most of the questions are mixed in different sessions. That's fine. All right. Now consider the following statement with respect to sum S, which is x plus y plus z, where x, y, z are distinct prime numbers, each less than 10. So less than 10 prime numbers are 2, 3, 5, 7. That's it. 2, 3, 5, 7. So this sum S is a sum of any of these 3 prime numbers. Any of these 4 prime numbers, you have to pick any 3. So that would be your sum S, right? All right. So the units digit of this sum can be 0. Just check it out. 7 plus 3, 10. 10, no. So 3 plus 2, 5 plus 5, 10. Yeah. So x, y, z. Yes, the units digit of s can be 0. Definitely true. So the units digit of s can be 9. Okay. Let us add these and check whether you get a 9 here. Whether you get a sum of 9. So to get sum of 9, 7 plus 2 will give you 9, but these are only 2 digits. And no other way. 5 plus 3 is 8. You need only 1. No. Let us check 19. You get sum of 19. Let us add everything. 7, 3, 10, 15. No. Maximum you get is 15. So you cannot get a 9. You cannot get a 9. Done. Let us see if you can get 5. Yeah. 7 plus 3, 10. 10 plus 5, 5 is 15. So you get a universal digit of 5. So statement 1 and 3 is correct. So 1 and 3. Yeah. This is your answer. Let's move to the next question. What is the universal digit in the expansion of 57242 power 9 into 7 into 5 into 3 into 1? All right. So you need to find the universal digit. I already told you 2 power. Just find the product of this. Find the product of this. Divide by 4. Check the remainder and do it. 2 power that remainder. So you have to find this product. So 9 sevens is 63 into 5 threes is 15 into 1 is that 15. So 63 into 15. 63 tens are 630. 63 fives are would be half of 630, which is 315. So this is 5, 4, 945. So this is nothing but 57242 power 945. So unit digit is 2 power 945. And this you have to divide by 4. Find the remainder. 44 goes. So 2 power 1. Remainder is 1, right? 44 goes. So 2 power 1 is 2. So 2 is your unit digit. So this is the one. Next, let's move on to this. How many zeros are there at the end of the following product? Same question, same repetitive question, same concepts. You have to pause it and solve. Do not wait for me to solve. You pause it, solve it. If you're not getting it, then come back. So, sorry, this is 5, right? So it's 1, 5, 10, 15, 20, 25, 30, 35, 40, 45. You have 50, 55, and 60. All right. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, good. Yeah, to find the how many zeros are there, trailing zeros, right? To find the trailing zeros, find how many fives are there. Very simple. And also, yeah, that should be enough. So here we have 1 5, here you have 1, here you have 1. So here you have 1. In 25, there are 2 5s, remember. Here you have 2, here you have 2, here you have 1, 1, 1, and here also 1. In 25, 50, 75, you will be having 2 5s. In 25, 50, 75, you will be having, even in 100, you will be having 2 5s, because this is 5 5s. Here this is 25 2s, 25 3s, 25 4s. No, rest of them will have only 1 5. This is 5 6 30. 1 1 1 1. Here you have again 2, here you have 1, and here also you have 1. So your final answer would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So number of trailing zeros would be 14. Yes, I hope this is very clear. See, if you observe, most of the questions are in the same line. So whatever the concepts I explained you in the beginning of the lecture, those must be good enough for you to solve most of the questions that come in this exam. So yeah, with this we have come to the end of the session. I'm not making the video too long, because in class 2 I have taken 1.5 hours, and I felt that you people are feeling difficulty in sitting for 1.5 hour session, so I try to make this short. I thought I can make two to three topics in one session, but now I feel like one topic is good enough. So I'll stop with this, and in the next session we'll start LCM and HCF and we'll complete it. So every day I'll be putting a video. I thought alternative days should be good, but now I feel like posting a video every day at 6 p.m. in the evening. I hope the session is good and you enjoyed it. So I'll catch you up in the next session. And do not forget, if somebody have not watched the previous session, class 2, it's in the playlist. Please go and watch it. Well, see you. Bye.